Okay, so hi, this is Selena. This is my air rocket activity, and what we had to do was, measure the times for the low cap, the medium cap, the high cap, and the super cap. And for number one, we had to sketch a diagram of the situation, use arrows to represent position and velocity. So right here, I drew arrows going up and then going down to represent how the bottle cap moves up, and then it has a velocity of 0 at the top, which is its maximum. And so I drew that for number one. And for number two, so I did that for every single one, right? I did the same thing. I made it go down, made it go up and go down, and then I wrote their times. So those are their times. And the same thing for the velocity graphs. Like for this one, the time was 2.67 seconds. So that would be the final time. And then since we know that the rocket is going up and then going down, we know that the first half is approaching 0 because it's slowing down, so the values are getting smaller and smaller until it reaches its maximum at 0. And so that's right here, and then it goes back down, so that's the negative side of the graph. And then since it went up and it came down the exact same amount, the same exact height and velocity, then these two triangles are the same thing. And then for the acceleration graph, what I did is since the low cap took 2.67 seconds to travel up and down, and I knew that our acceleration was -10 because of gravity, I just multiplied those two to find the change in velocity, and that's the answer for number 3. And you know this because that's how you find change in velocity. You take your time and you multiply it by your acceleration, and you get that. And now, since we know that 26.7, well, negative 26. No, this is 26.7. The change in velocity is negative 26.7 meters per second. Now, since we know this, we can infer that this whole thing traveled, the whole velocity is 26.7 meters per second. So what I did is I divided for the next problem, I divided this by 2, and I got for v naught, which is the initial velocity, I got 13.35 meters per second. And so this would be our value up here. That would be the starting point. So that would be our height, the velocity, and then for v final, it's negative 13.35 because they're the same exact thing, so they're going to have the same values, except this one's going to be negative because it's going to be below the horizontal axis. And then for number 5, it asks, is the speed when the rocket was launched different from the speed just before the rocket hit the ground? So they're not different. One of them is just negative, but they're the same value. Their absolute values are the same. So they're not different at all. They're the same exact thing since our graph is the same. And then for number 6, what was the maximum height of the rocket? How did you figure this out? So what I did for number 6 was the maximum height would be found from one of the triangles, right? So what I did is, because we don't know this part, we don't know what our maximum height is, so what I did is I took the area of a triangle, so 13.35, that's our height, times half, times base, which is our base. So for this is our base, and this is our height. So if our height is 13.35, we have to multiply it by this base. And since we know that our entire base, the entire length, is 2.67, you just divide that by 2, and then you get the half. So then you get this part, and that's 1.335. and then 1/2 base times height. So you just divide by 2 and you get 8.91 meters, and that's for this graph. So this is the maximum height of the rocket, and so then it tells us for number 7, what was the acceleration different when the rocket reached maximum height? Explain your reasoning. So for number 7, I put no, because the acceleration of Earth is always constant and it never changes. That's how we know. That's how we knew that like the acceleration right here was -10, because Earth's gravity is always going to be 10. So like that's how I knew that the acceleration was never different, because since we were using the rule of like gravity is 10 in terms of acceleration, then we knew that it was never going to be different, because if it was different, then it wouldn't be 10. So yeah, that's how I knew 10. That's how I knew 7, sorry. And then number 8, what was the total distance that the rocket traveled? How did I figure this out? So for number 8, what I did was, so if the maximum height of, so I used number 6 because this was our maximum height for one of the triangles. So if one of our triangles is 8.91 meters, then I know that both of them together, which is the total distance traveled, is 17.82 meters. So what I did was I just multiplied this by 2, and I got 17.82 meters. And then the total displacement was the total distance, the total, for number 9, the total displacement of the rocket. What you have to do is like, you have to add both V naught and, well, what I did was I added these two, because I know that those were two velocities, and I got 0, and that makes sense, because if the rocket traveled the exact same time, if the displacement was like the same on both sides, then it's going to equal 0, because this is like +1 plus -1, you get 0, and that's like your net like distance, kind of. And so I got 0 for that. And then so for number 10, it asks us, are your answers different for the last 2 questions? Why? Yeah, of course they're different, because number 8 is asking for total distance traveled, and that's just this, and that's just this. And then 9 is asking us for displacement. So of course they're different, because the total distance traveled is completely different. Well, not completely different, but like it's not, a change in position. So yeah. And that was for number 1. That was all the steps that I did for not number 1, for the low cap, and then I just repeated the same thing in the medium cap. I knew that my time was 4.17 seconds, and I put it right here, divided it up, found my acceleration, so that was my change in velocity, and then I found V naught, V final, and then I found the maximum height, and then I found that the acceleration was not different, and that's the same thing for all of them. It's basically like the same concepts. So yeah, that's all of them are basically the same. I just did the same thing for every single one. The only thing that was different was the numbers, because it would take longer for like the higher caps to go up and come back down. So yeah, that's my air rocket activity.